Alright guys, I don't know if this is part 4 or what part this constitutes, but this is the part where I show you guys the mill. And I've already done a fair amount of work in the box as well. So I'm not quite sure how long this is going to be, but we'll kind of go over stuff. So I have a Milltronics Partner, and I don't know if it's a version 1 or version 2. I don't exactly know the moniker. It's a very early CNC mill. It's got, from what I understand, it's got DC servo motors, and it's got an old Pentium 386 or pre-Windows, I'm not sure. And so what we're in the process of doing is we're making it so that one VFD can control 2 pieces of equipment. At first I thought it was a magic bullet, but after doing some reading, it's not quite the magic bullet that I thought it was going to be. So basically, if you're going to have 2 pieces of equipment running on one VFD, you set your VFD to control the largest motor. And in this case, it's a 5 horsepower mill, and I think a 3 horsepower lathe or a 2 horsepower lathe. So again, I'm not sure exactly what I'm saying, but supposedly, or the way I've read, it offers less protection for the 2 horsepower motor. I'm sure somebody way smarter than me understands what that means. So I think what I'll do is take you guys over here to the mill and show you the way that it was set up. I already have the mill tore apart. I may have mentioned it in the last video, but it was in an effort to make sure that I could actually do the modifications, because again, if the control box is complicated, the inside of the mill is more complicated. So let's go over what the way it existed before I took it apart was quite simple, and we'll kind of go from there. So basically, power came in through a NEMA, what is it? A NEMA L30. What is this? L15-30. It's similar to the one I've got for the lathe, but it's a 30 amp plug. And I cleaned this all up. This basically looked like that. And so it was just trashed. And so clean the cord up. Cord comes in the bottom here. Basically, there's a transformer here, and they are tapped in like this. So it transforms 240 to 120. And I'm assuming that's 243 phase. It's one of the phase, 2 legs of the phase. And that drops it down to 120. And I don't know if that's with a neutral, since it's center tapped. It may have a neutral. I don't know. Again, outside of my expertise. And then what they had was they had this Baldor VFD. So this converts 3-phase 60 hertz to 0 to 400, and basically it just allowed them to control the spindle motor and be able to run it up or down. I don't know how much. They had this VFD bolted right here, and then the wiring from this VFD, let's see, the power into the VFD came out right here and went to the VFD. I labeled them. And then power out from the VFD to the motor comes out right here, goes into this spindle enable box, and that has forward and reverse. And then that runs directly up to the motor. It runs up to the motor up there, the 5-horse motor. It has a air-powered drawbar And then this part of the VFD, this came from the VFD. This is all the low voltage wiring, and that runs to the e-stop, speed control, and then some type of forward reverse, 2-stage forward reverse. And so that was kind of the custom wiring that they had, that the electrician had set up for the machine where it was. It had 3-phase power. I'm thinking it was 240 3-phase and not 480 because of the way they have the transformers both labeled as 220, and then it's using the set of legs that transforms it from 240 down to 120. So that's the overall operation of this machine as far as the electronics outside of the control panel and the PC that's inside the box back here. Alright guys, we're inside the machine. I'm only showing you this because I believe it may or may not help someone. Obviously this is very specific to this mill. So the power comes in the bottom here, and it's 3-phase, and you can see by the 3 wires they've got. They used a ground as a hot, or neutral as a hot, and I did the same thing on one of mine. And this is 4-wire, so there's 3 hots here, red, black, and then black, white striped, quote unquote. And then you've got a green wire that's wire nutted to ground, which isn't wonderful. I don't know why they did that. And then this goes up to, sorry, let me see, let me find a place I can put this. So this goes up to these fuses, these fast reacting fuses. So the wires came in the top, and they came in up here, and then the wires came out of the bottom, and 2 leads, the 2 outside leads went to the transformer, and then out of the transformer they feed they feed down, and one side of the transformer goes to pin number, what is that labeled? I can't even see the number. Is it A2? Yeah, it's A2. Goes to A2, which, can you guys even see that? So one side of the transformer goes there to A2. The other side comes down and goes under and through this fuse right here. And I think goes to the bottom side. There's a bridge rectifier in here and some other, there's a, you know, there's the filter, and there's all this equipment that is specific to this machine. The 110 also came down, or excuse me, the 3-phase also came down. All 3 of these wires go into a line reactor, or maybe a load reactor. I'm not exactly sure. And that's right here. That's this Baldor 3-phase reactor. And then these go out to the, I believe, the VFD. Yeah, those are the top wire that I showed earlier in the video. And they go, you can barely see it back there. They go out right there and go to the input of the 3-phase VFD. So the line reactor was, yeah, this is a line reactor. This is on the line side of the VFD, the feed side. It'd be a load reactor if it was on the motor side. So I don't exactly understand line and load reactors. I know they're supposed to condition the For a line reactor conditions the power coming into the VFD. I think a load reactor conditions the power going to the motor. Not sure the significance of them. So what I'm trying to figure out is whether all of the systems in here are 110 or if there are some 220 systems. Now, the contactor looks like it might be powered by 220, so I have to follow the power out of the contactor. There's a supplemental contactor on top that I'm not even sure what it does. Bunch of wiring in here that's very specific. So the goal is to get this thing powered up, make sure that it comes on over there, that it's actually working. I'm hoping that happens here very soon. And then the other thing is just to wire the motor itself over to the VFD and get the settings in the VFD correct. So that's what we're trying to do. We'll move over to the box and take a look at that. All right, so I haven't filmed in a little while. You guys won't, be instantaneously on the video, but it's probably been months. Well, I think I started on this mill in end of October, and I just, with the way my designer drafting job works, I just get on these big jobs and can't get in here and spend significant time on the mill. So what I figured out, and I won't belabor the process, but I'll shortcut it for you guys. So if you own a partner, a Milltronics Partner Mill, basically the whole entire computer system in the back runs on 220 single phase. The only three-phase part of my particular mill, with I believe it's a 5-horse three-phase motor, is the motor itself. And so what they had at the shop this was installed at was 220 three-phase. And I got into the wiring in the back and did all kinds of stuff. And so what it had was what I believed and is in the old catalogs as a three-phase VFD. And it's a ball door three-phase VFD. So they go by frame size, and the frame is a E-sized frame. And let me get my glasses on. So the model number is an ID 15H203-E. And so it takes three-phase and three-phase and converts it into three-phase that can be conditioned, meaning you can change the hertz and use low voltage control to control the spindle motor. So the power coming in was three-phase, went into a GE transformer, which I believe most of them have on the side here. It converts it from three-phase 220 down into single-phase 220 for the machine. And then that's further broken out into 110 volts for different systems in the machine. The three-phase 220 that went from the wall outlet at this shop went through a line reactor and into the VFD. And then that was further controlled by low voltage output or low voltage control on the front of the machine, which controlled the motor. Hope that made sense. And so what I have done, I've converted it over to 220 single phase on the back of the controls, and it's still three-phase for the motor. Now, if you've been following any of my videos, you know I do all my controls over in that box over there. And so I have to have low voltage wiring that runs back to the box. Oh, come on. And, sorry, I get tired of holding this thing up. And so I'm going to show you where things plug in, and it's going to be kind of confusing, but hopefully I'll be able to clear it up for you. So the front of the controls is a period correct speed right controller for the front. And that was tied into this ball door VFD. And the ball door VFD, actually, so I got the manual, and these can be ran single phase. So turns out you take two legs down to, I think, T1 and T2 or L1, L2. and then you jump her over from L2 to L3, and these can be ran single phase according to the manual. So if you break it, I'm telling you what it says in the manual. You can go download it online. So then for that speed right control, that was this wiring here. And you can see I labeled all the controls. This was the side that was hooked up to the speed right system. I believe under this heat shrink tubing here, there's for some reason, a diode underneath this, and there's a little circuit board. I think this is a factory installation from SpeedRite, but I'm not sure. So my new VFD doesn't have all those controls. The ball door is a much better VFD. I'm not using it because I already have that box over there. I'm actually gonna, now that I'm understanding more about VFDs, I'm gonna go to a different setup. Probably gonna sell that as soon as I can find the time and find someone who's interested. I'll build another box offline and then pull that one down and stick the new box up and then have that for sale to somebody. So in the meantime, what I'm doing is I'm going to run, let's talk about the power. So power up here, we're going to turn this around. So power up there, you can see that this line here is 220 main power for the system. It's a twist lock connector. And then this line here is 3-phase from the box over there. And that's going to be to power this 5-horse motor right here. And then control wiring is the blue wire up here. And it comes out right there. And it's going to go into that right there. So while we're at it, we'll go ahead and show the wiring diagram. So this is as-is wiring. And you can see how they had this wired into the VFD. This is as-is. There's a note here about page 3-9 in the manual. This is what they call 3-wire control here. Then you've got your potentiometer up here. And then you've got your reset trip stuff here. The wiring itself is actually here. And that's how the system was wired, as wired. When I drew it, the speed control is actually backwards. This is looking from the front. You can see there at the top it says front view. So if you flip the board around, this whole thing is mirrored. So that's the as-is wiring. It's going to be very simplified from that because the VFD is a Chinese piece of junk. You know, in hindsight, I would have bought a much nicer VFD. I would encourage you to do so. I could never afford a ball door. They're thousands of dollars for the bigger ones. What I could afford, though, is a quote-unquote name brand Chinese VFD. You can get them on AliExpress. You can get fairly high-quality VFDs from them. There's 2 different name brands that I was able to kind of look up. And as much as I hate to even recommend AI, because I'm totally against it, I have been using it to do a bit of research. You know, it's hard to figure out when you're new to an industry, what's name brand, what's not, what the terminology is. So I've actually been using AI to distill down terminology for myself. I'm having it do market research on branding so I can quickly source different brands, different connectors. Cloud42 just did a video and he's using, so they're called D-sub miniature connectors, and they're like those old school VGA connectors, but it turns out they're very robust, very cheap. They have a wide temperature rating that they can operate under. You can get them sealed. You can get them metal backed for harsher environments. So, you know, it's funny how it kind of clicked that he used D-sub connectors in his latest project, because I looked up Molex and I looked up Amphenol. I can't remember what the other name is, and those are more expensive. The Molex connectors are nice, but maybe a little harder to terminate and more expensive. And then the Amphol, I can't remember how to pronounce it. Those are military, and they're very expensive, and definitely can't afford those in my little home projects. So the D-sub connectors, they've got all different kinds, so that's what I'm going to be using moving forward on anything that's more than 8 pins. But I don't even know where I was going with that. So what I'm doing is, you can see that the pot is soldered, and I don't even know if I'm going to be able to use that. It's a RPM gauge is also soldered, and I don't want that. I don't want them soldered connections. So what I'm going to do is I'm going to place a little piece of DIN rail in here, and then I'm going to use terminal blocks to connect up those two pieces of equipment so they can be disconnected when I want. And I got a little bit of fooling around this afternoon with seeing what makes this run and how I want the controls to work. And it boots up, it throws a fault. Haven't quite figured that out yet. It's it's not over travel, but it's basically a like you push the E-stop, but the E-stop's not pushed. So I don't know if it checks the motor for being enabled. There's a spindle enable system I still got to figure out in this thing and what that's tied to, but I'm getting close. So hopefully we'll have this thing running this next week or even possibly today. Alright guys, we're back at it again. What happened the last time, which will be a clip just before this for you guys, that I was working on the mill, is I got it to go into startup mode once, or boot, whatever you want to call it, Milltronics software, DOS, and there was some type of soft limit or hard limit or something airing out, and it wouldn't let it go into any sort of runnable portion of the program. Possibly operator error, maybe me not knowing how to reset limits or what. I don't even remember what the error was because it only happened once. Then the second time I started it up, I can't even remember if it would boot into the software, and now when it starts up it's looking for a specific configuration file, which I have on floppy, but what I don't have is the ability to run any sort of DOS commands because I don't have a full keyboard. I only have the front panel. So what I'm going to do to start out with is I'm going to make I can't even remember what they're called. I think it's PS2. Let me grab the keyboard. It's this style connector here. And then on the computer, there's an even older connector. And I can't remember, I believe these are they're a Molex connector, but I'm not sure. So the even older connector is that style there. The bulkhead connector that I bought online is this one here. So what I'm going to do is I'm going to hook this cable up to this bulkhead connector, and I'll be able to plug an external keyboard in outside the metal box. Now, I have future plans for the mill. What I don't want to do, I was hoping that somehow I could get software that would talk to the DC servos. I don't know if you can emulate DOS properly for the CNC software to run. What I'd really like to do is have a Windows XP or 7 machine in here with lots of RAM and hard drives and whatnot. There's a whole rabbit hole about networking a drive so that DOS can see it and Windows 7 can use it. I have not gone down that rabbit hole yet. What I'd really like to do is get a more modern operating system, even though I do like the conversational ability of the Milltronics software, you can go to what they lovingly call SBC on the CNC zone and other places like that, single board conversion. But you're still in the thousands of dollars. And if I'm going to spend thousands of dollars, I'm putting AC servos on this thing and running, you know, Linux CNC, or what I'd really like to do is convert to Masso G3, or I don't even know if they have a G4. I just don't know all the pitfalls and all the good things about each one, and basically, like every home shop, I'm trying to make the conversion for the least amount of money with the highest quality, right? So wherever those lines cross, least amount of money and highest quality. And I'm sure I don't even know if Mach 3 will run servo drives. I need to look into it. Again, don't know what the conversion looks like. I know the servo drives are the biggest cost if I can't use these DC servos. So right now I'm going to try to go get this machine running with its original software, with the cables that I have and an old keyboard. Sorry, this is a funky angle, but it is what it is. Okay, I can take the tape off. There's one. Come on, step it. Okay, we're up to 3. Just gotta make sure. Nope. Now that I'm wearing metal particles. There's 4. I'll get the vacuum in there at some point. Oh, it's so close. Hate to go to 5, but there's 5, and that's going to be loose. Probably a metric size. Yeah, it's not terrible, but it's not great. All right, got the hole drilled. You guys can see the hole there. I'm going to vacuum that out. And that's just behind the E-stop there, but it doesn't hit the E-stop button. Alright guys, so 17 millimeter. These are the washer and the nut that goes on the inside. So we'll get this mounted up. Probably not going to show it because it's bad lighting and there's not much to see. I'm going to tighten a nut up in a very tight space, so not super exciting for you guys. Alright guys, back on the mill project. I finally got the right connector. Make sure if you get a bulkhead connector, it's a 6-pin, not a 4-pin. So basically we're going to go from the circuit board to this connector, which is that on one end and that on the other. Sorry, I'm trying to get them in the light here. Then this cord is going to go from the board inside. It has the same connector on each end, male to male. And then this is the bulkhead connector, female to female. And then here's our old school keyboard, with a male connector. So anyways, we're gonna get this bulkhead connector in. All right, what I don't like about this fitting is it doesn't have hexes on this side. So I had to very gently put those pliers on there to get it to snug up properly. So that's not super wonderful, but it is tight inside. Requires a 17mm deep socket where I put it with a wobbly to get down in there. All right guys, keyboard installed. And hopefully you can see it just barely. There's the screen. I listed all the files. So I have access to the computer at the DOS level. Now I get to remember how to work inside of DOS. So it has to do with the the CMOS battery that's back there. It's they replaced it. It's a lithium battery, but I think it's bad, so I think I'm gonna have to replace it again. Hopefully it's real cheap. I got to copy a file from the A drive to what is this? This is the B drive, and I should be able to get the CNC software to boot back up. So at this point, keyboard's working, DOS is working. Now that I know that the keyboard works and I can type gibberish, I'm going to move from this point to the next point, which is getting the software running again. So we'll go to that. Alright guys, I think I found the problem. I couldn't get the machine to start, and it's because I jammed this safety switch. You can see the bottom one's jammed in. So in order to get to that, I have to take this whole thing apart. Also, this wrap is screwed up, and the prior owner wrapped it up with electrical tape and obviously didn't know how to fix it. So we're gonna do our best to fix it. Hopefully it's fixable. I think it is, and we'll see if this thing will start up. So we'll get to it here. Okay, tiny screws. Yeah, we're gonna attempt to fix this cable that's pulled out. Okay. So this cap just has a rubberized boot. So we'll clean up this sheath and then cut off the part that's damaged carefully. In the meantime, we'll take this apart here. I got paint on it to tell somebody if it's been tampered with. Okay, we'll take these little tiny screws out up here and see if that lets me take the terminal blocks off. That's for here. Keep disassembling, yep. Still spring loaded, so hopefully that's part of the problem, or part of the solution, one of the two. Alright, I'm an idiot and didn't start the camera somehow. These switches hook onto this plate here. They slide on from the bottom. And this plate, I believe, was up and down. Let me see if that fits. That doesn't fit. So I'm pretty sure the plates were actually like
this, with this block being pointing to the right. This is how it was set up. So they slide down and then the plate is pointing down. Plate comes off. The plungers are non-removable and they're pretty stuck, so I'm going to see if I can get them freed up. Alright guys, I got this limit switch freed up. Works really good. So these switches, I couldn't figure out where these springs go. These springs adjust the position of the switches and where they engage. They go here, and then the adjustment screws go through them. So we're going to try to get them on one at a time here. Doesn't take much movement to actuate it if you listen. So we'll get the other one in here. Oh, that one doesn't engage as quick. All right. Now we got to fix this mess here. So I need to cut all this off and get back to good material. And I'm going to have to shorten these dumb things up. Alrighty. Let's see if we can get this cleaned up here. Is that all exposed wire? It is. So this is all exposed wire. It's all shorted out. Dang it. Stupid people. Gee, I wonder why the contact quit working.
Alright guys, so I am not quite sure how the switch works. Let's see, it would be normally closed, normally open. Yeah, I don't know, we're going to see. It would seem to me that, I don't know if the switch would be open or closed. We'll find out. But normally closed. So I think the switch opens, but I'm not sure. So let's turn this on and see if we can get it moving around. See if the OS will load. I need to replace the CMOS battery. Escape, home, emergency stop condition. It's that. Oh gosh. So, not only was this one cooked, this wiring was, I didn't show you guys, but off screen the wires were all touching and melted. And this was jammed. On top of that, someone had ran the Z-axis down to the lower limit, and once it sets off the limit switch, I'm going to have to look in the manual or read online, but I couldn't get it to come off the limit switch. It was like it was a triggered emergency stop. So I moved, there was a little bit of room, and I moved the switch. Well, also, this antiquated program doesn't tell you what Z is. Well, Z on the keyboard ended up being, I wonder if it's plus here. No? Okay, so on the keyboard, the equals, the far left keys, the top one on the I'm sorry, I'm slightly dyslexic. The top one on the far right and the bottom, second to bottom one just above enter are up and down on Z. Man, that sounds crunchy. But it does work. I don't know how to do this at all. The forward and back works. I wonder if rapid. Huh. Left and right keys work. Okay, I had my feed rate turned down. So what does that do for... Not sure what that is. Gosh, I hope I don't have to take this thing apart. That'll really piss me off if something is mechanically wrong inside of here. Anyways, so it ended up being both switches, this one and the Z-axis or the head. So she's moving under her own power. Turn it back down to 20. Like I said, I know nothing about this old DOS program, but at least she works. I wrote down how the VFD was wired, so I'm going to have to look and see if somehow they had it plumbed into the machine or if that just stopped the spindle. We're going to call it quits here for this time. I've got to replace the CMOS battery so it quits forgetting who it is and where it's at and all that. On this old machine they were soldered in, and thank God at some point the guy had it replaced with something that's a lithium battery that I can just buy another one that doesn't run out of juice. So the next video will probably be me doing a lot of cleaning. Probably put this back together on that video and make it something else. And then we're going to investigate why this is clunking, if it's a mechanical issue, or if it's a problem with the tuning on the DC motor. Hopefully get all the low voltage for the VFD put in. I've got to figure out, I want one E-stop, and I want the E-stop to kill all of the drives and the VFD. I want the thing to power down if something's happened. Got to do a little research. I had to order number 4, which also corresponds to an M3 screw. I had to order number 4 ring terminals because the screws are so small in this limit switch. Anyways, we're gonna wrap it up. This has been a long video series. This is actually spanned, you guys won't know this, but this has spanned either 4 or 6 months of me screwing around with this thing. So cannot believe it's been that long. I'm so happy that it's running and that I know at least the drives all work, with the exception of the this drive here. Gosh, what is that? Is that Y? Anyways, I have a steep learning curve from here. I got to learn an antiquated conversational programming. Got to make sure limit switches work. I got to figure out how to get off the limit switch without having to take the damn hard stop loose. So we're gonna wrap it up. If you own one of these old machines and yours is running and you haven't converted it over to Masso or Mach 3 or something like that, then hopefully this will be informative for you. One of the very next things I'm hoping to do is swap out the CRT for LCD, but what I'd really like to do is just get this thing put back together and get it sorted out and actually do a couple of canned machine cycles. So, gosh, this is a long outro. Hope this helps somebody. Talk to you guys later.